Okay, so once again you are most welcome. My name is Mtanda Samir. Now this time around we are in for our item 5 of the marking guide Wakissha 2025 mathematics specifically. And now please, item 5 comes in a very special way. Item 5 comes in a very special way. In fact, it is coming from vectors, which is one of the rare settings, actually rare ones. And I would beg you should look. In fact, if you're in senior 4, you better list look at this item, and maybe if you're a teacher still, the simple advice is please make sure you have taught vectors already, because I know some people tend to hesitate and just be like, can it be examined, can it be said? Okay, here Wakissha brings you alright good news or shocking news. So vectors can as well be said. And now item 5 of Wakissha gives us one of the best scenarios as far as vectors are concerned. Anyway, big shout out to whoever set this question. So please, some of these questions here, a disclaimer, are just sent by people for hope. So I hope no one finds it offensive. I don't know. Anyway, so without wasting time, maybe before I proceed, let's look into what this question is going to have. Please, this is a video which you must not watch halfway. You must watch to the end. And I think with that, let's see what I'm going to have in there. First of all, take a glance. Alright, that's what we have. That's what we have. Okay, you see? Now, we are going to, in the long run, this is how vectors look. Of course, I'm only doing this for the students who may not know what vectors are. In simple terms, they're just something like that, something like that, something like that, something like that. And of course, guess what? Whenever you find vectors, this should be your partial expression. Whenever I find vectors, this should be your partial expressions. This should be your partial expression whenever I find vectors. Just smile, of course. Alright, so whenever I find vectors, just smile. Just know it's all done. Alright, good. Now let's proceed. So that's just a simple glance on what you're going to have next. That's how vectors look like. Let's now go and look into it bit by bit. Alright, good. Let's go there. So we simply remind you to subscribe, like, share, and comment. We simply remind you to subscribe, share, like, and also comment. As simple as that. Okay, so without wasting time, I think let's get there to our mighty question of Wakissha. Anyway, let's go there without wasting time. Okay, here we are. Okay, let's go through the same. Francis deals in buying and selling of land. He has a plot of land on sale at Uganda shillings 15 millions. He also sells it at a higher purchase by accepting a deposit of 60% of the cash price and then pay shillings 815,000 per month for a year. Okay. However, Zura does not have cash and she wants to buy this plot, but not sure of the total amount she will pay for it. So it means that in simple terms, Zura wants to buy on higher purchase. If you can really look into that. So they're saying, Francis has a land surveyor to mark the boundaries of the plot. The surveyor marks 3 points O, A, and B in a triangular form on which OA is equal to vector A, OB is equal to vector B. Points C and D are placed in the middle of OA and AB, respectively. Another point E is to be marked on BC such that BE is equal to 2/3 of BC. Now, those bars you're seeing on top mean a vector, position vectors. Okay. In fact, where I seeing a capital letter, position vectors. Okay. Francis wants to know if, in fact, here we might have the word Francis wants to know if the points O, E, and D are collinear so that he pays the surveyor. Next, what is the total amount, rather in the text they are saying, what is the total amount that Zura will pay for the plot? Remember, Zura is buying on higher purchase. I clarified on that. Express the vectors O, vectors BE or EBD in terms of vector A, vector B. Remember number 2, should Francis pay the surveyor? Anyway, of course he should be paid. Anyway, that's just a kind of a joke. You never know, maybe the surveyor may not qualify to get the money. So I think with this, let's simply analyze. Now part is saying, what is the total amount that Zura will pay for the plot? Remember, Zura does not have money, but remember here, now what you must know is you can buy stuffs in cash, and then you can buy stuffs on hire purchase. Okay, now I will explain a little bit. What we call hire purchase is the way how, in fact, you all know of what we call the M-Copper motorcycles, M-Copper phones. What happens in M-Copper is a good example of what we call hire purchase, like that. Then of course you can buy a phone from M-Copper. That is what you call, some people call a loan, some people call it a loan, anyway, but it's hire purchase. Then you can also as well go and buy just a phone on cash, like that. But of course we want to see, but what you should know is that cash is always better than hire purchase. Only that hire purchase enables even someone who cannot have that much at that time to achieve any good side, and in the long run can also enjoy the services with just the little money available, which we call the deposit in simple terms. So since this man is also sells on hire purchase, and then also Zura does not have money cash, if you don't have cash, then of course you can buy with the hire purchase, and that gives us our part A of this question. Let's go there. Okay, now part A, let's start off. We should now have to remind ourselves of the unexpected from the question. So that's what you have in the question. They're saying he also sells it at hire purchase by accepting a deposit of 60% of the cash price, and then pay shillings 815,000 per month for a year. Per month for a year. Okay, now whatever you see in that color there is always an extract. That's how shall be going. Whenever you see that color, it is an extract from the question, to avoid you referring back to the question. Now, since we have that, let's remind ourselves, since they are buying on hire purchase, Zura does not have cash. So let's remind ourselves of the formula for hire purchase. So we say hire purchase is equal to a deposit plus installment. Alright, good. But then we need to get our deposit. Let's begin with this. We want to begin with, first of all, how shall we get the deposit? Let's begin off with the deposit. Okay, and with that we shall have, so deposit is equal to, the upside is 60% of the 15 millions. Alright, good. Now remember, the cash total was 15 millions. Maybe I just take you back here. Okay, now you see that the land, if you are to buy land on sale, the land is only 15 million. That is the cash, 15 million. So that's what I'm going to refer to here. That's what I'm using. Okay, good. Now here we are. You realize that it's 60% of the cash price, but cash price was 15 million. Now a 60% can be written like this in fraction form, if you can really see that, and when you apply the two, this times what you have here, you get 90 million Uganda shillings. Okay, now since you have a deposit, you must as well get installment. So installment is equal to the money times time. Now this is the simple way I make it to be a simple framework, that installment is equal to the money times time, whereby, now let's look into this, the cash price, and then you pay shillings. This is the money, you see that about installments. Then for a year, this is now the time, but here they said what? They said per month installment. So a year has how many months? 12 months. 12 what? Months. And let's get that multiplied. So we shall have installment is equal to 815 times 12, which will give us a 9,780,000. So we have installment and also have a what? A deposit. We shall again remind ourselves of the formula of hire purchase, that hire purchase is equal to the deposit, which have there, plus the installment, which have here. And with that, we shall have the total as 18,780,000. That is the total when someone is buying on hire purchase. Now, before we proceed here, let's analyze. Now, cash price was how much? Cash price was 15 millions. You see that? Then buying on hire purchase, you see? If you're buying on hire purchase, you buy at 18 millions roughly. And if you're buying on cash, you buy at 15. So which one is better? You realize that cash is better than hire purchase in the long run. Now, with this, we have our part A of this question answered. Maybe let's conclude. Now, we shall always be using green ink to have our conclusion. So we have Zura will pay Uganda shillings 18,780,000 for the plot, and that marks the end of part A of Wakissha 2025. Let's go to part B. Let's go there. We refer. So they're saying part B. Remember number 1, they're saying express the vectors BE, OE, and BD in terms of A and B, like that. Now, before you express that in a vector, you must always come up with a shape, by the way. But then you shall formulate a shape here. How are we going to formulate that? Let me first of all clear this off. How are we going to formulate that? Now let's read slowly. They're saying here, it starts from here. Francis has a land surveyor to mark boundaries on a plot of the plot. The surveyor marks 3 points OA and B in a triangular form. So those 3 points in a triangular form are like this. Just trying to get your sketch. Those 3 points in a triangular form are like this. If you can really see that. Okay, good. The points are O, A, and B. Any order you take brings no harm. Okay, good. In a triangular form, okay, on which OA is a vector A, meaning that when you're going from O to A, that is a vector A, like that. Then from O to B, that's from O to B. I'm showing the arrows. Take note of the arrows. That is vector what? B. Okay, good. Respectively, another point E is another point E. No, another point C and D are placed in the middle. Point C and D are placed in the middle of OA and AB respectively, meaning that point C is placed in the middle of OA, and point D is placed in the middle of AB. So where is midway AB? Get another. Okay, where is midway AB? OA midway is here. I will maybe shade it a little bit. Shade it. That is it. And which point is that? It's a different ink maybe. Which point is that? This is point C. That's point C. Then point D on the AB midway, like this. And that's our point D in simple terms. Okay, if you can really see that. Now those are midway. Let's proceed. Another point E is to be marked on BC. Another point E is to be marked on BC. But remember here you have C, so you must go from up this side, like that, like that. And now that's our line BC, if you can really see that. And the point E is marked onto there. So let's get our ink here. And point E is marked onto this. Point E is just right there. Okay. Be marked on BC such that BE, where is BE? Such that BE, where is BE? B is here. BE is equal to 2/3 of BC. Okay. We have that connection. We shall see how that is important also. All right, what next? Francis wants to know. In fact, here there is that word there. Francis wants to know if points O, E, and D are collinear. Now, collinear, remove this word here. Col. Remove it off. Then move off this AR. Are you seeing that we went with the word line? Okay, good. So the points O, E, and D make a line. So the points O, E, and D make a line. So there is that line also, like that, back there. Hope you can now see our sketch coming out. In fact, vectors are the simplest. You should pray them bring one in the forthcoming exams anyway. Okay, good. Now since we have that, let's now go there. Now they want to express the vectors BE, OE, and BD in terms of that. Now you can only do that expression if you have this sketch already drawn. You have the sketch there as a rough cut. Let's now go and see the real drawing, and then we get started off. Okay, good. Now let's get our sketch drawn. First of all, let's get our sketch drawn. That's the sketch I was made the other side. That's the sketch I made the other side. That's part B, number 1. We are getting it answered. That's OA, vector A. There you have vector B. Please, you must now I know someone may ask, you must always, when you're writing, you must as well also put these vector symbols here like this. You must put them there. Don't forget, they must be there. In fact, the way you're seeing it right there. Okay, let's get our now. I see that the triangle is appearing somewhere like the one we had sketched earlier on. Okay, there we are. So, but remember this one here. Now let's get. Okay, now let's get a simple reminder of, they said in the question that point C and D are placed in the middle of OA and OAB respectively, meaning that where is OA? OA is right here. Now point C is here, so point C is in the middle, meaning that we have a half this side and we also have a half this side of that line. Then also point OA, in fact we even have a rough cut of it here. Please, we have removed the point O, it's here, point from O to C to A. Now we have a point from O to C to A. So I've made an extract to avoid the congestion. I've made an extract of this. Now it means that if point C is in the middle, then what must you know? This side we have a half, and even this side we have a half. That's what we mean right there. Now if you have a half, what does it mean? That then implies that point OC, this OC is equal to, you get a half times the whole line OA, and then this side point CA is equal to, you get a half, since it is the middle, from C to A is a half of the whole line OA. Don't know whether I can really get that or follow that. Let's get it in writing. So now if you have that point OC is equal to a half of OA, please, what you are putting these demarcations here mean position vectors. They mean position vectors. They must be there. Without them, you have no mark. So now let's get, but remember, let's also get this side. CA is equal to a half of OA. Why a half? It's because I've said middle. If you are in the middle here, it means this side you have a half and this side you have a half. That's what you mean by middle. So now, but what is our OA? Vector OA is the same as A. From writing the question here, they told you. Please allow me to resolve this off since I've already explained. Please, they've clarified for you that point OA is equal to vector A. Where you see OA, you can put small letter, and where you see OB, you can put small letter B. And of course, the question is saying that change, express change. Where you're seeing the capital letters, you must write them in terms of small letters of small letter A vector and small letter B vector. That's what you want to do. So where we see the capitals, we substitute them with the small letters which correspond to that part. So we have got to know what OA and what OB is. Let's now go there and substitute. So let's substitute. OC will now be equal to a half A. Alright, have a half A like that. Have that also have a vector, and also there a vector in simple terms. So here, please, are you seeing? Okay, let me resolve this. Vector OA, but OA is the same as vector A, so we have here the half has been maintained. CA is equal to half of that. We have right here like that. I hope this is really making some sense. In fact, this topic vectors, please, as a teacher or student, you must make sure at least you know part of it. You never know they can bring it as item 5 in your name. What will you do anyway? Just a simple joke. I don't know. It cannot come. I don't know whether it can come. It can as well be said because it's on the syllabus. I'm just asking what if when it comes anyway. Okay, I would say God forbid, but anyway, we are all mathematicians, so we don't need to fear some of the topics right here. Okay, good. Now what I'm doing here is that I want to break down for you what this means, especially this point C. What does it mean? And then I want to break down what this point D also means. Remember, D was also halfway of the line BA. So I've broken down what C means, and then with that we have gotten what OC is. From here up to here we have gotten what it means, and from here up to here we have gotten what it means. So we want to know what does it mean from here up to here, and from here up to there. Why am I doing this? I'm basing on the points that I've given us in the question. The point C, where you see the dots. I see this dot on this line. Finished, dealt with it. I see another dot here on this line. I want to deal with it in the next part. So I will say. But of course, before we proceed, please just know that whenever you have a combination of letters, say for example, AB, then they put up like that. It's more like saying, in fact, maybe I just sketch it for you here. If you have this one as our point O, and maybe a point starting from here like this, also like that, like this. Those are two different points. I have to make a sketch here, and this is our A, and this is our B. Then of course they will ask you, which one is the shortcut of moving? Could you be knowing of a shortcut to move from? In fact, apart from using a shortcut, how can we find route AB? How can we find route to AB without using a shortcut? So to move from A to B without using a shortcut, what else can we use? So you find that you can move like this. AB, now you start with the first part is A, going towards B. So from A we can move AO, that's AO. You can see that plus. Next part you can move from O to B, then that is OB. I hope you can really see that. Now, in vectors, what we must know is that we all know that OA vector is equal to small a vector. Now, any change in direction, any change, now this one is going in that order, but any change in direction, and then if you start with the A, if you start with the A and then you come on with the O, if you have changed the direction, then it means that you will attach a negative onto that vector there. Any change in direction, you attach a negative. Now, does it mean that AB is the same as what? The same as AO is the same as negative A vector plus OB is the original way. OB is the original direction. So, B vector, like that. So, AB will be the same as, in fact, it will be the same as vector B minus vector A. If you can really see that. But the simple problem marker is, whenever you have OB, you just say OB. Whenever you have AB, A and B, to define it in vectors, you say OB minus, you start with O of this last letter minus O of the first letter. And then I substitute, this will be vector B minus vector A, which really brings you back to what you have done right there. So I think that makes some sense. Let's get that here. Then you have that AB is equal to OB minus OA. Substitutions shall have vector B minus vector, vector A. Now with that, let's get our line drawn. Which line is that? Of course, remember we have dealt with the C, and we have it right here. Every dot, where every dot is, now I want to go deal with the D. Remember D also was in the middle, meaning that this side you have a half, and this side you have a half. So it means that AD will be equal to a half. If to get AD is equal to a half of the whole line AB, then the whole line AB. Hope you understand that. Then you have DB is equal to a half of the whole line AB, like that. Then next you're just going to make substitutions, and then there we move. So let's get there. Shall have AD is equal to a half of AB. Then let's substitute in, but remember AB from here, AB is B minus A. So you substitute where it is AB, you put this, and we have it right there, vector B minus vector A. So next, DB is equal to a half AB again. Then shall say DB is equal to a half brackets B minus A vector, and also their vector. Now, what you must know is that what I'm doing, I'm first of all breaking down the diagram so that you understand it. You now know what it means from here to here. You now know from here to here, it is dot you have here. You now know what it means from here to here, it is right here. Now you now know what it means from, from here to here, AD, and that's what you have right here. You now know what it means from here to here, that is DB, and we have it right there. I hope you really understand that. Okay, now that will make some sense, some bit of sense. And now with that, since I'm finished to deal with all those points, it is now done with it all. Let's now go on to what do they want? What do they want in the question? A simple reminder here, they said let's try to get this. Now they're saying express vectors BE, OE, and BD in terms of that. So we're going to begin with BE first of all. We go to OE, we go to BD. Expressing is more like changing. So let's go back there. Okay. Now still shall redraw our diagram again, our triangle again, because this is our working point. We redraw it, and then we see the way forward on how we can find BE, on how we can find BE. Alright, good. And then I'll be specifying for you in green. I'll be specifying for you what we are dealing with at hand. I'll be specifying for you what we are dealing with at hand. Alright, good. Let's get everything done here such that we can proceed. Please, my advice is watch this to the end, and at least if you're a student, you should beg your teacher to teach you this topic. If you're a teacher, still you have time and do or cover this topic with your students, because you never know what may come. They may just choose to set a question from here anyway. Alright, so let's get started. So with this, let's remind ourselves in green ink what are we going to have now? First, we want to say expressing BE in terms of small a and small b vector and also b vector. Now, if you can really see here, how can we get BE? Remember in the question, I'll remind you a bit. Remember in the question we had something of this kind if you go back in the question, but from BE is equal to over 3 of BC. I hope you saw that somewhere. You really saw that somewhere. You really saw that somewhere. Now, but how are we going to get this? What is our BE? We have B right here and we have our E right there. Now, how can we get BE? How can we get BE? Now, we have very many ways. BE is equal to, in fact, BE. Here they're like asking, how can you move from B to E without using this root here? It means that from B to E, you can use this root. We name it, that is root BO. So BE is equal to BO plus, again from there, use this root back here to E, up to OE. That's one root we can use. But again, any root to use must be a good one, which is not risky. Let's ask, do you have BO? Yes, we have BO as it is defined there as B. What about, do you have OE? Is OE defined? No. So it means that that root cannot be used. We have cancelled off that root. It can't work. Which other way? Let's try. Still about BE. Still about BE. I'm telling which other ways we do vectors. B is equal to BE. How can we move from B to E? You will go via BD plus, okay, DE. You see that? Meaning from here up to this, from here up to there, then from there up to there. Are you seeing that? We have that. But then just ask, do you have BD? Yes, we have BD. By the BD, we have it right here. BD is here. In fact, whenever you see, if it is DB, DB is equal to a negative of BD. You can really see that. Any change, if the letters, say for example, if you have AB is equal to a negative of BA. Once there is any change in the letter, you always attach a negative. You should memorize that. Whenever there is change in the order of letters, so AB is equal to negative BA. Say for example, if I have XY is equal to negative YX, that's what we do in vectors. So DB is finally there and is defined. So we have DB, but then just ask, do we have DE? Do we have DE? Not really. DE, where are you? DE is here. We don't have it. So what does it mean? None of those roots can work, and you have exhausted all the roots. So even this one here is a wrong turn. So if all of them are wrong turns, what are you going to use? Now it means that to get that answer, we have to use this information they've given us in the question. You remember they've given us in the question. You can rewind the video and check on that. Now, does it mean? It means that to get BE, we need to start from this meaning here. Because here they're telling us that, for the rest of this, they're telling us that to get BE, you can just say 2 over 3 of BC. So it means that what we need here is to find BC, then we multiply it with this, we shall have gotten that. So, but how shall we get BC? BC is equal to, let's see what is BC. We have B here, and we have a C here. How can we get BC? BC is equal to how many roots? Let's see. Okay, now you start with the first letter here. So you start from B. We have that BO downwards. So we have BO plus, then we have OC. So long as you have reached C, because you're moving from B to C without using a shortcut. So you also have plus OC. That's one root. Maybe just ask, do you have BO? Yes, it is vector B, negative. Do you have OC? Yes. Remember OC, we defined it in the very start, whereby we said that OC is equal to a half of vector A. So we have also this one. So you realize that this one is a good root. However, you can even try another one and say, how else can we get BC? BC is equal to, oh, we can even go via this BC. We can go via BA plus, okay, AC. You see that? Now, is BA known? Yes, BA is known because BA is vector A minus vector B. I've defined that. I've told you what we do when you have a letter like this. You start with this last letter whereby you say OA minus OB, like that. Okay. Now, but of course, again, don't be funny that when you have OB is equal to OB minus OO. No way. This cannot work. If it's like this, then it's a position vector right away. There should be letters of different what meanings. Now, one would ask, what about BE? BE is equal to OE minus OB. Now here it would work, but do you have OE defined in the question? No. What we have as defined was OA, which is equal to vector A, and OB, which is equal to vector B. So only these ones which have defined is the ones we used to define to write in that format. Okay. Alright, let's proceed. So we have got to know the root. So we start with BC. Once we find the BC, we shall come and substitute here and multiply it with that. We shall have the answer already at hand. Now what does it mean? It means that BC is equal to BO plus OC. But we already have this, you all know. To remind you, BO is the same as negative B. Of course, I've told you that from the question, OB capital is equal to small b. Now when you change the arrangement of letters, then you write BO, then you attach a negative. I've explained that in vectors. Once any change in letter appears, you also change the sign. So you have negative b. Then next, OC, where are you? Now OC was originally half a from the very start. We had that right here, just to remind you. So OC, we had it here. That's what I was trying to explain here. What is OC? OC, okay. OC is the same as half a. If you can really see that. Okay. With that, let's proceed. Alright, good. Since we have that, now we shall need just substitute in there. So we remind ourselves of the formula BC is equal to, okay, now you realize that BC is equal to, now BO has been that, we have substituted and we have it right there, plus we have it right there. Now OC, we have it as this, half a, and we have substituted right there. When you try to simplify, O, it's good to always begin with, let me rub off this. Okay, so it's good to always start. This one is a negative, so let's rephrase the statement and say BC is equal to a half a, okay, a half a minus b right there, half a minus b right there. But then from BE is equal to 2 over 3 BC. Remember we started from right here, so we now have our BC as that. Now we can come back and substitute right here, and then we shall have that the next step, that B is equal to a half brackets BC is a half a minus b vector also right there. Please, these vectors here I'm putting down, they are not for formality, it is a must be there. Okay, now with that, let's proceed. Now having gotten this, now we multiply, just enter. Now here it is simpler to enter a 2 to multiply with that, meanwhile leave the 3 here, then also multiply a 2 right there. Then what are you going to have in the next step? When we multiply, of course you all know a 2 times a half, so here times 2. Okay, let me resolve this so that I can explain this part. Explain what has happened here. So what has happened here is that this one here times 2, and even this one here times 2. Now what does it mean? The 2 cancels out with this, and that's how we have that a. Then a b times 2, that's how we have a negative 2b vector right there. Now thanks be to God, we have our BE. Remember the question said express, and the question said we should express in terms of BE, OE, and BD. So we have finished BE. Let's now go to OE. Let's now go to OE and see how we can express that. Still again, we shall repeat ourselves. We shall repeat ourselves with the drawing again. Let's repeat ourselves with the drawing again. This time around, we want to see how we can get OE. This time around, we want to see how we can get OE. Please, I'm repeating the drawing such that you can easily make a follow-up and for its explanations. I'm repeating the drawing such that you can really get there and also be able to get this explained. Okay, so our diagram is right there. So let's, I think, start off. Still again, I'll remind you that we are expressing OE in terms of vector A and vector B. I hope you can really see that. Now, what does it mean? Where is OE? Where is OE, by the way? Let's get mark of OE. Where is O? It is right there. Where is E? It is right here. Now, what does it mean? OE. It's more like, how can you move from, they're like asking, how can you move from O to E? But without using that shortcut I've given, without using a shortcut, use the other routes apart from using this direct route of from O to E. Use other shortcuts, however much they may be long, but they will move. So OE, how can you get OE? O is the same as, please, from O to E. Now the first letter is O, so you also begin from O. So you have O. I can move upwards like that, and that is OB. You can see that, plus. Then I can come downwards like that, and that is BE. If you can really see that. Now just to ask, do you have OB? Yes, OB is B. Do you have BE? Yes. By the way, BE is right here. Just to remind you. Yep, we have BE right here. We have BE right there. Okay, so like we have that. So let's go back. However, maybe what I'm going to do is, maybe I will also write for you other routes. OE can't be just got by that alone. OEs can also be got from O to E. You can move like this. OC plus OC, meaning from O to, okay, from O to C like this, that route. Then from C to E. Then from C to E like that. Just ask, do you have OC? Yes. Remember, OC was a half A. Now, do you have CE? Nara. So we don't have CE. So therefore, we find that the only route we can use is this guy up. And then we shall pick up from there. We say, but from OE is equal to OB plus BE. We have it defined there. All right, good. Now, what does it mean? We have OB as vector B. This one here is vector B. And BE, we have it defined. Maybe, just to remind you, OB was equal to vector B. And BE is equal to that answer you had gotten in the very first part, and all those are vectors. Please, these wave lines I'm putting down are not for formality, they must be there. Okay, now let's proceed. Now we're going to substitute this right here, this right there, then we have this simplified. So let's go there. But O is equal to OB plus BE, therefore we substitute like I've explained, vector B plus brackets a third vector A minus vector 2B. All right, remember this has been our vector OB, this has been vector BE. In fact, the whole of this is vector BE and the whole of this is vector B. Now let's get that simplified. Maybe I just break this down for you. So OE will be equal to, here that is a fraction, our LCM is 3, so this one is over 1, maybe just to help you out. 3 divided by 1 should give us a 3 times now this B to give us 3B vector, plus a 3 divided by 3 to give us a 1. 1 times the whole bracket, we have vector A, okay, vector A minus 2B vector. Now simplifying, what are we going to have? You find that the like terms will subtract 3B minus 2B, we give you B vector, plus the A vectors remained there, but again over what? Over 3. That's what we're going to have in the next part or next area. Let's have that. So vector O is equal to, when you get to try to get the LCM, that is harmonizing a little bit. That's a simple repetition anyway, but let's get it in LCM format. LCM will be 3, and when you do the magic, that's what you come up with. When you do the magic, that's what you come up with. And now what does it mean? It means that by simplifying, you'll have that in the end. Why? You subtract 3B minus 2B, you get a B. Meanwhile, the A has just remained there. So OE is equal to AB plus A over 3. Simply, we have our A. Okay. Or in simple terms, you can factorize out the 3 and write it in this format, which will be 1 over 3 brackets B plus A, since they're all sharing the same denominator. So far, so good. So far, so good. We are moving. Okay. Okay. Hope you can see vectors are very simple. Now let's proceed. Remember, let us find it. Okay, BE. From BE we find the OE. From OE we find the BD. But no worries, I'm always reminding you in this very first part here. Okay, now with that, let's go and find BD. Let's go there. Still going to draw our Venn diagram, rather not Venn diagram, but our vector diagram again. We draw it. Please, for you in the exams, you can use 1. Here I'm only bringing it forward to avoid repetitions and going on to other pages. Okay. So now we get our diagram drawn, we're putting the markings. No need to explain. We have already drawn this. This is almost the third time getting this drawn. Okay, so we get it named. Then of course this time around, guess what? We are in for B and D. We are in for B and D. We are in for B and D. Okay. Now remember, since we have that, then we are expressing what? So express BD in terms of vector A and vector B right there. So, but you all know that, please, we got to know this in the very first part about BD. Let's go there. Let's go there. Okay, right here. Allow me to wrap this. Okay. Now BD, where are you? Are you seeing here? We have DB. If you can really see this, we have DB is equal to a half B minus A. Are you seeing that? Hoping you memorize that, we go up to the other side now. DB is equal to a half B minus A. That's DB. Let's go back there. We refer. Let's go back there. Let's go back. And here we are. So it means that, please, what you should know is that we have our DB as a half. Okay. A half, our DB as a half vector B minus vector A. And maybe let's start it right here. So our DB was equal to that. Now, okay, if it's equal to that now, once you're changing this from DB to B to D, if you're changing like that, then you must attach a negative right there. You must attach a negative right there. Please, this negative is not there. This negative, you call it off. So now remember, it was DB and it was a positive. So when you just start with B, then later D, you must attach a negative there. So it will be a half brackets a B minus A. And now when you apply in there, our BD will become what? Our BD will now finally become, okay, will now finally become a half vector A minus B, because you only enter the negative. When the negative applies with B, gives us negative B, and when the negative applies with the negative A, gives us a positive. And then that's what to come up with. And then here we shall have that BD is now equal to a half. Now mark the arrangement. I think that here it was DB. We started with B minus A, but here we have changed this to come here and this to come over there. So BD. Therefore, you are starting with A and finally with B. Hope you can really see that the effect of this negative I put here. Hope you really understand that any change in direction leads to a negative. What I'm meaning is, if this is O to A like this, then if you're moving this direction here, you'll have a negative B. If this is O to A, if you're coming from A to O, you have a negative A. That's what I mean. If you're moving in this direction, move 10 meters. When you come over this side, opposite way, you move positive 10. They must, when a change in direction gives us a positive. Alright, now since BD, now BD will be equal to a half vector A minus B. Okay, we have it. It has just been a simple walk over since we had already gotten it right there from the start. Okay, lastly, what do you think? Lastly, what do you think? They want us to part B Roman number 2. Let's go there. Part B Roman number 2. Let's go there. Now I have it right here. Now part B Roman number 2. We have it right here. They're saying, should Francis pay the surveyor? Okay. About paying the surveyor, where is that? Why should Francis pay? They're saying another point E is to be marked on BC anyway. Francis wants to know if the points O, E and D are collinear, so that he pays. So it means that he only pays the surveyor if points O, E and D are collinear. This statement is very common in vectors. Let's go and do. We see how we can prove the collinearity of points. Let's go there. Shall again have a pattern of the statement from the question right there. Okay, so we have that already. Lastly, let's get still our Venn diagram, not Venn diagram, but vector diagram drawn for one more time. No worries, we're about to finish this. In fact, we are about to finish this. Okay, anyway, it is worth it. You should watch this video to the end in simple terms. Okay, now what does it mean? It means that Let's get this drawn. 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 Okay. 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 Now this is what we had right in the other side. This is what we had the other side. I don't have to repeat myself. This is what we had in the other side up. We have already finished this. When we're finding, please, when we're finding BD, we have already finished this right up from the other side. Now I want to start off with Roman number 2, which is talking about what we call collinear points. Points O, like point O, E, and D, are they in a straight line anyway? So we say a simple reminder. Francis wants to know, in fact, yeah, there is the word, that word there, no, left it out. So Francis wants to know if points O, E, and D are collinear. Now the word is collinear, you can really see there, collinear. Now what if we remove these first letters here, we erase them off, then these last two letters here, we erase them off? What do you remain with? You remain with the word line, meaning that you first do a straight line like we have done here, and you put those points there, O, E, D. The way they are O, you can just find that text dot right here. You draw them. Now what does it mean? In order for the lines to be collinear, then it means that they must satisfy a certain ratio. Say for example, for the lines to be collinear, we shall say that OE, shall say that OE, sorry, shall say that OE to this to ED, OE to ED must give us a fraction which says that OE of ours over ED. Once we substitute in this and get our answer, that will be then they will give us what we call a collinear point. Let's get that in writing. Okay. So we are saying that BD OE to ED is equal to, of course you all know that in ratios, once you have say 1 to 2, it can be written as 1 over 2. Please better know ratios are the same as fractions. 1 to 2 same as 1 over 2. So OE to ED is the same as OE over ED. Now, in order for us to get done, we must get this. Do we have OE? Yes. We have OE. I've already found it. Please, we have OE and it's right here. We have OE and it's right here. Allow me above. We have OE, it is right here. Like we are. So therefore, let's go back and ask ourselves, do we really have ED? Do we have ED? We don't have ED anywhere. But is there a way we can get ED? By the way, is ED. So ED is from here up to there. So how can we get ED? Which simplest way? Now, one way you can get ED is through, so ED is equal to, how can we get that really? Okay, so ED can be, someone can go via EB, that is it, from here upwards, then from there back here. That's ED plus, now any corner you take, if you move from here up to here, then once you are turning any corner you put a plus. So it was ED, EB plus BD, so plus B and D. Now let's ask ourselves, do you have this? Oh sorry, this was EB, sorry, EB. Now do you have this? Do you have EB? Just ask, do you have EB anywhere? Yes. Now EB is the same as BE, which we calculated in the very start. Very good. Then we have BD. Yes, BD is just right here. So like we are, maybe just remind you a little bit, we have BD and we have BE. Let's see that. Let's see that. So we have those ones already found. So EB is equal to EB plus BD. So let's see how we can get those ones there. So we shall say that, but EB is equal to negative A vector B. Of course, let's go back there. You really see that what we had as our BE, you can really see from here, by the way, our BE was this, meaning that if you want to find the EB altering the direction to now be negative a third, you attach a negative there, vector A minus 2B, and that's what we have right in front there. Let's go back. Let's go back. Let's go back. Okay. Okay, now I think that's what I have here, negative. But then this negative comes and affects this. Negative times this will give you a negative. Negative times this will give you a positive. So we shall start with 2b. And then we shall have the story as EB is the same as a third 2b minus A. If you multiply this negative in here, that's how you come back to that answer. In fact, what you do, you first remove this third, leave it silent. Then you deal with the negative into the vector A minus vector 2b. Now multiply negative, this is the one. Negative 1 times A, you get negative A vector. Now a negative times negative will give you a plus. 1 times 2b will give you 2b. But it's good to start with the positive, so we shall start with the 2b. A 2b minus vector A. And that's what we have, right? Okay. There. We are aiming at finding the collinear point. And how can we find the collinear point? Collinear point is say O to E to E to D. Then after there, you first make a straight line of what they want. Like though you have it here. After there, you now put off the points the way they have given them to you. Then you come and say from the first letter to the next to the ratio of from that letter to the other. So from O to E and from E to D. So this can give you a fraction. So OE over ED. You must have OE. Do you have OE? Yes. Do you have ED? It's then we are finding. Once you get them, you bring them here and you divide them. Then you have the collinear points. Maybe let's go on the next part and get that substituted. So you finally have that. A simple reminder again. ED is equal to EB plus BD. So let's have that. A simple substitution. But EB was this from the other part. Then BD was this. Please just to remind you a little bit. We had this already here. If you can really see, allow me to rub this off. So we get a different ink. BD is right here. And EB is right here. And remember, you're substituting for this in that formula. And you're substituting for this in that formula right there. And that's what we have in the next part here. If you can see that. Okay, good. Now with that, we have this added. Now let's add. When adding here, what do you expect? We have here a 3. Now, what you must know is that when you write 1 over 3 into 2b minus a, this is simply the same as just 2b minus a over 3. It is the same as that. This kind of writing is the same. Hope that really makes some bit of sense. Okay, good. Having done that, let's see. Okay, we have the vectors already. So LCM here will be what? Our LCM will give us what? LCM here will be 6. If you can really see that. Now 6 divided by 3 gives here 2. Now we have this 2 here times this whole bracket which you have here. And that's what you have right there, right there. 6 divided by 2 it gives here 3. This 3 is multiplying this whole bracket right there. Usual way of dealing with the fractions. From there we shall simplify, multiplying in there. So when you multiply, you say 2 times 2 will give you a 4b. And the 2 times a will give you a negative 2a. Then 3 times a will give you a 3a. And the 3 times b will be given a negative 3b. From here, you just come and add. The addition will be how? Let's see here. How we going to add? You realize that the 4b will add plus this. 4b plus that, what will it give us? It will give us b. 4b minus 3b will give us b. Then negative 2a plus 3a. It will give us positive a. Then we have ed is the same as... Okay, simply ED is the same as vector B plus A over 6. And like we are. But then remember, from collinear points, from that, we should remember that. From OE to ED, which is giving us that. Let's now substitute. It means that O to D is the same as, now we're substituting for OE in green. And we're substituting for... Now, ED is what we have right here. OE, we found it back then. We have OE as a third B plus A. Maybe just to remind you here. Some people may have even forgotten what we have gotten this side. OE, where are you? Now you see that OE is here. You can really make a follow up here. So please, OE is here and is a third B plus A. If you can really see that. Can I go back? Can I go back? Now we have that. So we carry out the divisions. And lucky we are. In fact, I'll have this off. Lucky we are. You see that? This bracket is the same as this. So they cancel away. And then shall remain with O to D. OE to ED is equal to a third over 1 over 6. When you divide this by this, the answer you get will be a 2 over 1. Please try to divide it. In fact, let me divide it for you. It is a third divided by 1 over 6. You can see that. So to be therefore a third. But division symbol can't work out a fraction. So we multiply. We get a reciprocal 6 over 1. So multiply, we shall have a 6 over 3. and when you divide you get a 2 over 1, which you have just right there. That has been just as a by the way. That has been as just a by the way. Alright, good. Now with that, let's conclude. Therefore it means that you're going to go multiply. This will apply right here, and this will apply right here. And then finally we shall have that OE is equal to 2 ED. Now this one you have gotten means that these points are collinear. Are you seeing any cosine here? Yes, meaning that if you want to get OE, you multiply ED times 2, then it will be equal. That's what it means. That's what it means. Then finally, if they are collinear, let's conclude. We say, since OE is equal to 2 ED, this implies that OE is parallel to ED, but both pass through point E. Hence, points O, E and D are collinear. Therefore, he should pay the surveyor, and that marks the end of this question. In fact, item 6, it was a sweet one. At least I know you have grasped something little about vectors. Remember, here we're just in division, so maybe sooner or later we shall be handling topics by topics. That is the time to come. In fact, it's the next milestone. Then, of course, please, we have a paper for you here. Item 6 is waiting for you right here. So you have item 6 waiting for you right here. Item 6. That's what you have as our item 6. I want to at least end here. I wish you well. Please, item 6 will be uploaded soon or later. Item 6 will be uploaded soon or later. That is by tomorrow. In fact, you shall be having item 6. And now this is coming from item 6 is strictly coming from 3-dimensional geometry. Also another sweet topic. Item 6 is coming from what we call 3-dimensional geometry. Shall be picking up from there. Wish you well, nice time. Bye bye.